Hello, this is Christy Snyder. I'm going to talk to you today about Dosage Calc and why it's so important. I know that math may seem easy to you and you think you know how to do it, but in performing a correct calculation, we can ensure that our patients are receiving safe dosages. Medical errors is the third leading cause of death, and this is behind heart disease and cancer. Johns Hopkins School of Medicine actually did a report, and they found that medical errors were defined as an unintended act, either of omission, not doing it, or commission, giving them something wrong, or one that does not achieve its intended outcome. The failure of a planned action to be completed as intended, like an error of execution, the use of a wrong plan to achieve an aim, or a deviation from the process of care that may or may not cause harm to the patient. So approximately 1.25 million preventable medication errors occur each year. That's an extraordinary amount. 39% of those they found occur during the order process. That means the physician ordering and the nurses or pharmacy not catching it. 12% occurred during the verification process. That's when we as nurses go back and look at the order to make sure that what we're giving is correct and we're giving the correct dosage. And then 38% occur at the time of administration. That would be giving the wrong dose, the wrong medication to the wrong patient. So 40% of all errors are from Dosage Calc errors. So that's why it's so important that we talk about calculation and you learn how to do dimensional analysis to help you make sure that you have everything in that calculation that's needed to provide the correct dosage. So the four things that you need to know to do appropriate dosage calculation is you need to know what the given quantity is. That's the beginning point of the problem. And then we need to know what the wanted quantity is. That's the answer to the problem. Then we have to have a path. And that's a series of conversions necessary to achieve the answer to your problem. So we have to know of conversion factors. That's why I'm giving you a sheet on conversions from milligrams to grams, or micrograms to milligrams, or kilograms to pounds, or vice versa. It's because that's going to be an important part of your dimensional analysis to come up with the correct answer. And you'll see how all these come in to play. So units of measurements, we do use the metric system in medicine. kg is kilograms, g is gram, mg is milligram, mcg is microgram, cm is centimeters, cc is cubic centimeters, kl is kiloliters, L is a liter, and ml is milliliters. So here are the liquid units of measurements and the conversions. You really need to know that 1 liter equals 1,000 milliliters, 1 milliliter equals 1 cc. And then you also need to know, as far as weight, 1 kilogram equals 1,000 grams, 1 gram equals 1,000 milligrams, and 1 milligram equals 1,000 micrograms. And you may use the length sum, but mostly it's going to be liters to milliliters. Then we look at the household measurements, like pound and inch. And so I've listed the conversion between these two systems. You need to remember that 2.2 pounds equals 1 kilogram, and you need to figure out how to find that. And you're also going to need to know length. We measure in centimeters. So if you want to know what that is in inches, or if a physician puts their incision length by inches, you need to know how to convert that. Dimensional analysis is a unit of measurement that will help you. It's a formula to help you identify the correct answer and what you're looking for. So the first step is to find and identify the given quantity in the problem. And so that would be like the doctor orders a medication, 200 milligrams of that medication. And then we need to identify the wanted quantity in the problem. So if there's 200 milligrams, how many grams are we going to give? Then you need to establish the unit path from given quantity to wanted quantity, and that's using that conversion factor, and we're going to be working on that. And then we'll set up the conversion factors, and I'll show you how to cancel the unwanted units in a formula. With dosage calculation, we're not dividing the denominator into the numerator. We're multiplying the numerator across, we're multiplying the denominator across, and then we'll divide the denominator into the numerator to find the correct answer. And then the answer is the numerical value of the wanted quantity. So here's a sample problem. As you can see, there's 4 milligrams, and we want to know how many grams that's going to be. So our given quantity is 4 milligrams. And the wanted quantity, it's algebra, x over x grams. And so our conversion, we have to know the conversion, 1 gram equals 1,000 milligrams. So you'll see in the problem that I have 4 milligrams over x grams times 1 gram over 1,000 milligrams. And you'll notice that I've crossed through milligrams. So these are the factors that we can get rid of that we don't have to include in our formula. So we can cross out the milligrams and we can cross out the grams. So 4 times 1 equals 4 on the numerator, and then 1,000 milligrams times x is 1,000x. And then we'll divide 1,000 into 4, and that gives us our grams. Let's look at another. So this is a pound to kilogram conversion. So the problem, what we know is that this person is 120 pounds, and we want to know how many kilograms this person is. So our given quantity is 120 pounds. What we want to know is how many kilograms, x kilograms. And we know that the conversion factor is 2.2 pounds equals 1 kilogram. So you'll see that I have the formula listed out. So we want to put the given quantity on top. We always want to start with the given quantity. So the given quantity is 120 pounds. And then the wanted quantity is the denominator, and that's x kilograms. We have to put in that conversion factor. We know that 1 kilogram equals 2.2 pounds. So we know that we want to put what we're trying to find on top of this equation. So 1 kilogram over 2.2 pounds. We've crossed out pounds and kilograms, and then we've multiplied across the numerator across the top. That's 120 times 1. And then we've multiplied the denominators, and that's 2.2x. Then we multiply 120 times 1, and that equals 120. And then we have 2.2x, which is 2.2. We divide 120 by 2.2, and x equals 54.5 kilograms. You have some problems to work, and so you'll be putting these in formulas. And we'll go over these in class on Monday the 15th. So we're going to talk about one-factor medication problems. The first thing that we need to do is figure out how to interpret the healthcare provider orders. You're going to be learning more about this and hearing more about this as you go through this first semester. But there are 6 rights of medication administration, and these are so important. We have to give the medicine to the right patient. We have to give the right medication or the right drug. We have to give the right dosage, the right route, and we'll talk about that later. We have to give it at the right time, and then we have to use the right documentation. So here's a simple medication order. You might see that the physician or the healthcare provider has ordered ibuprofen 400 milligrams every 6 hours for arthritis. And the dosage that we have on hand is 200 milligrams per one tablet. So the given quantity, what the physician or the healthcare provider ordered, is 400 milligrams. Our wanted quantity is the number of tablets that we're going to be giving, X tablets. Our dose on hand, what comes from pharmacy, is 200 milligrams per one tablet. I want you just to stop. You can pause it right now and think about what information is important to compute this problem. And do we need to put the 6 hours in there? So for this problem, we don't need the 6 hours because we just want to know how many tablets per one dose. We're not wanting to know how many tablets per day. If it was how many tablets per day, then we would do that. And we'll do that later. But right now we're just going to work on the simple. So here's the problem. As you can see on the top, our given quantity is 400 milligrams. That's what the healthcare provider ordered. And our wanted quantity is how many tablets? X tablets. And then we're going to multiply that. We know that from pharmacy, one tablet equals 200 milligrams. Remember, on that supplied quantity or the dosage on hand, we're always going to put what we're searching for on the top. So we know one tablet is 200 milligrams, and then we're looking for X tablets. So on the bottom, in the second equation there, you'll see that I've got milligrams and tablets crossed out because we don't need those anymore. And then in the final equation, you'll see also in red that I've taken the zeros of the 400 and 200 and crossed them out because we can cancel those out since there's the same quantity. So what we have left is 4 divided by 2, and that gives us 2 tablets. So 400 milligrams is going to be 2 tablets is what we're going to give to the patient. So that's a simple problem. And so decimal places, let's talk about those. When you have decimal places, you have to know what they are. The first number behind in the decimal place is a tenth. 2 decimal places is a hundredth. You're going to have to read your problems very well to know what you need to round to if needed, or how many decimal places do you need, or are you supposed to round to a whole number? So 1 decimal place would be, that's a tenth, is 4.5. 0.5 is a tenth. 2 decimal places would be 4.55. You have to know the principles of rounding, and you have to know these and remember them well. If you have a number following a decimal and it's 5 or greater, you round up to the next whole number if that's what's requested. So the example for tenths, 4.7, 0.7 is a tenth, then you would round that up to the whole number of 5. But if you have hundredths, you may round to the nearest tenth. So that would 4.75 would equal 4.8. If the number following the decimal is below 5, you round down. So if you have a tenth, then you need to round to a whole number. 4.4 equals 4. But if you have a hundredth and you need to round to the nearest tenth, then 4.42 would be equal 4.4. The other thing we need to talk about are medication labels. You need what's composed on the medication label. There should be the name of the medication, and this will include the trade name, and that's the brand name. That's what the specific manufacturer calls their medicine. And then there's also the generic name. And what you need to really know is the generic name. That's what you're going to be tested on. The dosage includes the amount of medication either in tablet, capsule, or liquid form. Then we have how it's supplied, the form of medication. Again, tablet, capsule, or liquid. There should be an expiration date. There should be a lot number because each batch or each that has been run has a specific lot number, and that way we can trace it if there's a problem. And then it also should list the manufacturer of the medicine. So here's a medication label. Let's look at it. The trade name, the brand name, is Verilyn. The generic is Verapamil. And it says these are sustained release, and that means that the medicine releases into our system over a period of time. It says that there's 120 milligrams and it's per capsule, and then there's 100 capsules in the bottle. You can see over on the right, it says each capsule contains 120 milligrams of the Verapamil. And then it talks about where to find the usual adult dosage, but you will get that from the physician. Down on the very bottom, you see the control number. That would be the lot number, and then an expiration date, and they would have a specific expiration date. You'll see that Letterall is the laboratory that produced the Verilyn or the Verapamil. So think about what you might use from this label to help you in a problem. It would be the name of the medicine, it would be how many milligrams, and it would be how many milligrams per capsule, what the dosage is per capsule. I also want to talk about medicine cups just a little bit. We use this to measure liquids, and you'll see the measurements on the cup. You have medicine cups in your skills bag. I would highly recommend that you get one out and look at it. If we're looking at household measurements, a half a teaspoon is going to be 2.5 milliliters. 1 teaspoon is 5 milliliters. A tablespoon is 15 milliliters, and 2 tablespoons is 30 milliliters. These medicine cups are all 30 milliliters. This is the best way to deal with medicines. You can also draw them up in a syringe, and we're going to talk about syringes next week in class. So there are going to be problems to work where they're going to ask you to shade in the appropriate site on the cup. And this is on the worksheets. So you have worksheets week 1 through 4. They have some simple dimensional analysis problems. You might be asked to shade in on the medicine cup. You also will be asked to do conversions. So I want you to do the homework sheets 1 through 4 for week 1. Then bring them to class next Monday afternoon, as well as your skills bags, because we're going to get in. I'm going to have you draw medicine. I'm going to have you pour medicine. We're going to work with tablets. We're going to be doing dosage calc problems with dimensional analysis, and I'm going to have you draw up your answer or pick the number of tablets or pour it in a cup for whatever problem you're doing. I hope this helps. I'm in class on Tuesday with a level 2, but I will be available after 3, and then I will be in Learning Lab on Wednesday for those of you in Learning Lab if you have questions. But try to work the problems. Please try to use dimensional analysis. Once you figure out what you need in the problem, I really think it's an easy formula to work with. Let me know if you have any questions. Thank you.